Good morning, good morning, good morning. Please post on YouTube where you're joining us from. We'd love to see it. Pueblo, Colorado, which is a city I only know of because of the Dead Milkmen song Stewart. If you know that one, deep cut. I appreciate you. Pueblo, Colorado. Um, Quebec, Canada. Love to see it, folks. We'll get started here. I think probably now is a pretty good time to start. Let me fix our view here. Hey folks, welcome to OpenCV Live episode 172, if you can believe it. It's me, it's PHI-LLIP. I am your co-host with the co-most, the second banana who's second to none. I'm also your plus one and only. It's Mr. Nelson. If you're nasty, but you, my dear friends, can call me Phil here on OpenCV Live, and we have a banger of an episode for you. A little bit different than we normally do these. We've got Satya and a whole bunch of guests down in the Santa Clara Convention Center for the Embedded Vision Summit show. OpenCV has a booth over there. Satya did a workshop and a talk over there about OpenCV 5. We really appreciate Embedded Vision Summit. It is the premier conference for innovators incorporating computer vision and AI into products, and we are pleased as punch to be there. Stop by booth 704 today on the exhibits, and you can grab yourself some OpenCV merchandise. We got stickers, we got buttons, absolutely free to you. OpenCV is a nonprofit, and as such, we rely on donations from companies large and small. I'm going to do a quick shout out and thank you to our sponsors before we get started proper. Current OpenCV members are on the screen right now. Thanks so much to all of them. We really appreciate it. Also, OpenCV has merchandise 20% off everything. That's opencv.myspreadshop.com. Yes, and join us, Embedded Vision Summit, going today. We'll be there all day long. Buttons, stickers, and fellowship. Booth 704. All right. Satya, before we get started here, we got a little bit of business to take care of at the top. I hear there's a new OpenCV University course. Can you tell the good folks about that?
Yeah, so we have revamped our applications course, and in fact, we are running a promotion right now. It's a sale event, so people who have been waiting for buying the course, this is a good deal that is coming along. So please, go check out the new course on the website, opencv.org/university. It is a revamped version of our old course, applications course. So pretty good deal. And we are also running a sale. So please go check it out.
Yeah, fantastic. Appreciate that. There's also CVPR coming up in Nashville, Tennessee this June, 9th, I think. It's imminently approaching, and OpenCV will be there as well. So please come join us at CVPR, the Computer Vision and Pattern Recognition Conference. I'm just doing a quick double check of making sure our YouTube feed is good. Yeah, it looks good. Okay. I think now is a great time to get started. If everybody over there could please just go down the line and introduce yourselves and take it away.
Sure. We can start with.
Yeah, sure. I'm Megan Stronach, the product manager for Qualcomm AI Hub, which we'll hear about in a bit.
Great. Hi, I'm Blythe Towal. I'm the Chief of AI at ipop.ai.
Andy Ballester, Chief Product Officer at ipop.ai.
And I'm Satya Malik from OpenCV.
How'd that guy with the hat get in there? Who's that? Yeah, what are we talking about today, folks?
Excellent. So we thought it would be fun since we're here at the conference and we're doing a kind of live feed from the conference itself to talk about one of the booth preparations we did for IPOP. And so we wanted to build a badge detector for folks to come up and look at that demo. And when we think about computer vision, we think about there's a lot of different things that you need to do to build real computer vision solutions. We're going to be showcasing our platform today and how to build on our platform. And some of the things that we're going to take a look at today are how do you train a custom model? Like there's a VLM or zero shot will get you pretty close to badge detection, but for EVS specific, if we want to really get fine-grained localization of those badges, as well as just better accuracy and small, tight models that we can run locally, we want to train our own model. So we're going to showcase training your own model on IPOP today. We're going to look at that, and we've been working on this for the last 24 hours, so we've been taking lots of badge photos at our booth and just throughout the conference to train the model there. we're going to be optimizing that model through the Qualcomm AI Hub. And then we're going to be deploying it directly to this Snapdragon laptop and using the NPU on board to run inference locally for our demo. And so before we
Awesome. Can I butt in real quick to
Yeah,
ask what
absolutely.
model of Snapdragon laptop that is?
yes, this is actually, you know what?
It's the X Elite.
Yeah, it's the X Elite.
Snapdragon
Yes.
X
Yeah,
Elite.
yeah, yeah.
Okay.
We have a couple different versions of house. So I want to make sure this is the right one. But yeah, this is the X Elite. Yeah.
All right.
Great.
Thank
Yeah.
you for that.
Yeah, so I'm excited to show this today because it shows how you can really, build a capability, in very little time. We've done this, entirely at the time we've been in the conference. And what I'm really excited about, with AI and CV at this particular moment is it's really exciting to be able to bring capabilities into products. And so we're going to show you a lot about the model and how you use our, get it to actually deploy to these devices. But what I'm really excited about is, the tools that are now available through Qualcomm and iPop that allow you to, if you have an idea for a capability you want to bring into a product, you can do that very quickly nowadays with a lot of the things we have here. And want to make sure that everyone sees how quickly you can actually build for real computer vision applications.
And it would be really helpful if you explain to the audience what iPop is, because some of them may not be familiar with iPop. So just a few lines about iPop, that would be great.
Sure. iPop is a computer vision platform designed to make it easy for teams without machine learning experience to deploy real-world computer vision solutions into their product. We've done that by making the inference side very easy. It looks like web API calls with our SDKs. And on the training side, we built that into our platform so that you can walk step by step through a really accessible flow to get to a trained custom model.
So basically, user can upload their own training data, and then they can train the model and either have a web API, which you guys host, or they can also take that model out and deploy on an edge device. Okay,
correct.
Exactly right. Yeah, and so what we provide is not just the model, but the full pipeline. So we call this a POP. So it does all of the pre-processing, post-processing, handles the deployment on whatever hardware you're working on. If it's in the cloud, it's deployed there. You don't have to manage any of those resources. And the same, so if you deploy to the laptop, all of the compression and everything that happens to enable that is done through the AI Hub. Do you want to tell us a little bit about that?
Yeah, of course. So Qualcomm AI Hub is two main pieces. We have our AI Hub models, and then we have our platform, which allows anyone to come bring their own model or one of ours and optimize it for the edge device of your choice. So in this case, with our partnership with iPop, we're able to get them to bring the model. And of course, that can be the one trained on the iPop POP, and then go ahead and we'll optimize it. We'll compile it for the device of interest, and then we provide that model to the developer so they can go ahead and use it. And we also have a profile job which runs that model on the real device with the specified target runtime and gives those rich performance metrics. So you make sure that the model is running fast enough, it's running on the NPU, and it's running, with all of the right metrics so that you're confident and ready to deploy it. You can also check the accuracy of the model with our inference job and make sure that it's numerically accurate and doing what you're expecting it to do. And you can go ahead and quantize the model through AI Hub as well. And so then we give that optimized target model and you're good to go. So there's a lot done, behind the scenes, compiling it and converting it, making sure it's running well, that it's able to run on device. And then we try to make this process pretty nice and easy for the user and give back that optimized target model.
Yes, this has been a game changer for us, for our product, because we can then take that model that's been optimized for a particular device and put it into our runtime, which we then do the deployment to the device for. So really trying to, kind of move up a layer of abstraction of all the ways you need to think about and all the things you need to do and all the tools you need to manage. We take a lot of that complexity out of the process here and try to make it as easy as possible.
That's great. One last question. The audience must be thinking, what is the origin of the name iPop?
We were just thinking
You ever
about.
seen the movie? Have you ever seen the movie Scanners?
Yeah, it's not that. And actually, I faced some of that in the SEO world. But we wanted something, more visually pleasing than some of the tools we've seen out there. We knew we wanted it to be accessible, and so we wanted a name that would talk about the accessibility of to that. And so you get eye-popping results through our platform, that kind of thing.
I'm glad you did not call it the AI trainer.
Right.
All right.
Yeah, it sounds a little bit too much like exercise, you know?
Yeah.
Yeah.
As a reminder, folks, before we continue, we're taking questions from you in the audience. Use the Zoom Q&A button if you're watching on Zoom to ask your question at any time, or just post it in the chat wherever else you're watching, on Twitch, on YouTube, or on LinkedIn. I'm monitoring those, and I'll pick out the best ones a little bit later. Also, we've got our trivia giveaway later in the episode. Stay tuned, and you can win the OpenCV University course of your choosing.
Great. All right. Shall we get started?
Sure.
Thanks, Megan.
Okay, so today we're going to be walking through the iPod platform. We're going to be talking about what are some of the common things that users do there. We're going to look at training a custom model, and this is going to show the model we've trained over the last 24 hours. And then we'll get into the deployment piece on the Qualcomm laptop. So to start off with, this is the iPod dashboard. On here, we have different capabilities that we're showcasing in the form of endpoints. And these are endpoints that I've set up. This is you can set these up through the UI. You can also set them up just directly into code. And we'll be taking a look at how do I configure my endpoint here. I'm going to create it through the UI right now. And so we're going to name our endpoint. To start off with, we're going to choose a really common capability, which is a person with 2D body landmarks. And so there's several models at work behind that pipeline. All of our model pipelines work like Legos. And so you can mix and match any of the models that we have in the system with the things that you create on our system. In here, you can see and select different capabilities from our library here. And so common ones are detecting people, detecting vehicles, looking at text in a scene. Again, all those can be combined together into your own endpoint. We now have an endpoint, and we want you to get into code as soon as possible. And so we have made our SDKs really easy to use. You can see just a couple lines there for getting inference out of our endpoint. These examples showcase uploading an image. We're also going to use our preview experience just so you get a sense of what we're doing here. And so I'm going to upload an image into our new endpoint here. And so here we show a visualization of all of the data coming back. And so what an endpoint is to us is you should be able to add images, video, live streams, and get structured data back in a standard JSON template that you can then integrate into your product. It's much easier to integrate JSON in than try to determine the image yourself. Also, for folks new to ML, tensors can be a little bit daunting. This gives a capability to just jump right into coding around that. And so we can see here on the left-hand side, the visualization, the things our developers care most about is the JSON on the right-hand side. And so you're getting back a nice hierarchy of data around this person, their, where they are in terms of bounding box localization, as well as the key points that define them there. Okay, great. So that is iPop endpoints in a nutshell. And so we're going to create our own custom capability here, which is let's find badges now. And so you can see I have several models that we've been working on with customers and for demos. I'm going to go ahead and create a new one. We're going to go and we're going to create an object detection model. You can also create classification models, key point models. These are key point will come out later this summer, but that's something we've been working with customers in. So if you have a key point problem, talk to us. We'd love to help you solve that. And so we're going to create a new data set. This is our collection of images that we're going to use to train on. We're going to call this badge detection at EVS. And we're just going to have one class in here. We're going to call that badge. And so that's all you need to do to start off with. Now we're going to upload images in here. And so for this kind of test set, we're going to upload frames of video from a video I took yesterday at the conference. And so this gets uploaded in there. While it's getting uploaded, we're doing things in the background, like prioritizing these images, starting auto labeling around the class name I've given it. Now, you generally want more than 90 images in here, but just to show you this piece, then we'll jump over to the model we've been working on. So you can see here our auto labeling is happening in the background. Blythe, do you want to talk about our auto labeling?
Yeah, I'll talk about that. So, we mentioned VLMs and some of the other techniques that are out there, and these prompted models, if they work off the shelf for you, then you don't need to go through this step. You can use kind of the off the shelf approaches that Andy showed at the beginning. But for a lot of cases, they don't quite meet the mark, or you need something that's more precise than what it gives you. And so here we're running a prompted model in the background. We are, always experimenting with new and better models to make this process more smooth, but this allows you to basically have auto labels on all of your images so that you just need to go through and quickly review and maybe do some minor correction there. So we're really trying to minimize the amount of time that people spend in this labeling step. In addition to the auto labeling, we're calculating various statistics about your data set and the images themselves to make sure that we have a priority stack, a priority rank of the images that you are seeing here. This is a stage that I think is, not talked about a lot, but picking out the right images to label to train your model is something that's to some extent a dark art in some ways. So we're trying to basically make that happen automatically. So that you're, going to get the best bang for your buck, the best output for the amount of time you spend in the labeling or correction step. So that's what's happening under the hood here as we're ingesting the data set.
Excellent. And sometimes this requires a little bit of wordsmithing here. In this example, batch works pretty well for auto labeling. And so you're going to see this going to run through our auto labeling. We label 50 images, and then as you're labeling, start to label the rest of them. And so I'm going to point out a couple of things here. And so on the we have our dashed auto labels here. And so if it looks good, then you can just hit approve and you're good to go. Now I'm going to mess with the confidence on this a bit, because you can see our auto labelers will guess quite a few things. You may have to drag that box around a little bit, and but it makes the labeling pretty smooth. We can move through this pretty quickly here. In fact, our labeling system gets better over time. So as you train a version of the model, it will use that model to relabel the rest of the images that you haven't labeled yet. And so we very much like to take an iterative approach to model creation. Later, you'll see the model we'll be using today is the 12th version that we trained over the last 24 hours. And so just continually adding data and getting a little bit better every time. Once I've labeled there, actually, do you have anything else on labeling that you want to jump into?
Yeah, I wanted to point out, so 12 may sound like a high number to people, and they may think we've had an army of people in the background labeling and so on, but really we have not spent that much time on this. We've probably spent under how many, like
probably I would say 1.5 2 hours labeling total, something like that. Yeah, so nothing too crazy. Our account manager Shiroz, who's back at the office, has been helping us out while we've been here. But
yeah, so one of the things people may be wondering, right, is that this VLM that you're running in the background, why don't we just run that? And the answer is, these VLMs can be very heavy. We want a small model that runs on the edge. Even if you're running it on the cloud, you don't want to be spending that much computational effort because it's expensive, right? For inference, right? If you're running it on 90 images, even 1,000 images, that's not a big deal, right? The costs are pretty reasonable. But let's say you want to run it in production, right? Then yeah, there's this joke which says that, there are opportunities that knock at your door, and then there are opportunities that knock your door down, right? So the cost would be prohibitive for that kind of application. So using a heavy-duty VLM in the backend for on your training data, that's a perfect use. But then if an application is simple, like detecting badges, then you should create a more optimized model for inference, right? And that's what we are doing here.
Exactly right. So we're really using the VLM to help take a lot of the work out of the initial understanding of the images, and then distilling it into something that is small and will be easy to optimize for all of these edge platforms. I'll also point out that a lot of the applications we've seen need really precise key point and position information, and that's something that the VLMs they're getting better all the time, but they're not quite accurate enough for a lot of the use cases we see. So this type of system really lets you very quickly spin up those types of models, leveraging a VLM to get you close, but then actually taking it the last mile.
Excellent. Okay, and so what I'm going to do now is we're going to jump out of that test set. I'll show you our actual badge detection data set. We've been working on this. When you are done labeling your system, or you have enough labels, we'll give you a score of how ready you are to train on your data set. And so this surfaces things like how many images do we have as examples. If you're using multi-class, it'll break out those classes and give you a sense of, do I have enough representation of each of my classes that I'm going to be training on? We pull out examples like negatives, which may be important to this use case, so that we aren't getting as many false positives in our end model. And at this point, the first time through, when I hit start train, it's going to ask me several questions. These are really accessible questions that allow me to set up my hyperparameters and augmentation parameters behind the scenes.
Yeah, so I'll say, a lot of the training parameters and things, we're trying to, again, abstract, like move up a layer of abstraction for people to create these types of capabilities. So we've really focused on asking kind of end use case type questions, like will this thing exist outside, for example? That tells us under the hood a lot of the different transforms and things we should do with OpenCV in order to augment the data set.
Ding, ding, ding.
Or adjust things there. So we're trying to really focus on, again, thinking about AI as bringing a capability or an ability. So we're here not to, twiddle all the knobs and give you all those knobs to train the model. If you want those, we can expose those too. But we're trying to think about this really from the end user application and phrase everything that we're doing here in terms of that.
Excellent. And everything you see here, we're SDK API first. Everything you can do through our UI, we also have SDKs for. So if you want to ingest data programmatically, you can do so. You can hit the training button programmatically as well. And so this can be integrated into other systems for continuous learning and learning on the fly. All right. All right, so looks good. We are going to start training. While this is training, we're going to jump back over to a model that we've already trained in the system. And so let's do that. I can click on deploy on any of my models. Again, I can also do this programmatically as well. And actually we'll be using that on the Qualcomm laptop. I get a sense here of the performance of my models. There are some additional performance metrics that I can pull. By default, we can deploy it to the cloud very easily with one click. This UI has several of our common pipelines that people want to combine with custom models. So we can deploy directly with person and 2D body points. In that way, I get my badge and I also get the person around the badge. We could also couple this with text detection. So I get the badge, then I chain from the badge into a text detection pipeline to get the OCR of what they have on there.
Yeah, I just want to make a comment about that. I think that's something that's really powerful here. So a lot of times when you're training these models, if you know, for things like people and text, they're very well established models that do very well, that are very well optimized for those things. And so by leveraging those in a pipeline, so again in this POP concept, along with your custom object, you can very easily add a custom object without having to train a model around the entire use case of all those things. So we're really leveraging a lot of the existing things that are out there, along with the ability to customize a piece of what you're doing there.
Excellent. And so I've already deployed this model to my Android phone, and I've optimized it through the Qualcomm AI Hub. The first time through, you just put in your API key. That's what connects you over to your personal AI Hub. And then the rest of the way, you can just optimize by selecting the specific device that you're looking for. There are also family of devices if you have several. Now, this process usually takes a minute. I've sped it up here so that we don't have to wait. But we upload your model into your AI Hub. And then when it is optimized, we pull it back down and it is ready to use in your iPop pipelines. And so this goes out and optimizes. And now I have this Snapdragon X Elite optimized model in the background that actually looks like an Onyx model.
Yeah.
And so I don't know if you have anything else to add to that one.
Yeah, I will say, as Megan mentioned earlier, in the AI Hub, they have profiling jobs, they have inferences jobs to check performance. You can see exactly how many milliseconds this thing will run on this specific device. So since we are leveraging the AI Hub and your model is ending up there, all of that functionality from the AI Hub is available to you for this. So we pull it back and put it in our runtime, but it does exist in the AI Hub, and you can use all of their tools there to inspect or do anything specific you want to do for your use case.
And so our runtime is going to take these various models and you run it the same way regardless of the device. And so for the Google Pixel family, that actually looks more like a TF Lite model. And so my code doesn't change from here to the Qualcomm laptop. I'm just using this model UUID. And so we're going to go ahead and copy that model UUID, and we can use that in our iPop code to call that model as a capability in our badge detector.
So I have a question.
Yes.
From the code deployment perspective, let's say you're deploying it on the laptop versus the phone. So you have an API that would automatically download the right model for the right device, right?
Correct. Yes. Okay. And so the runtime is device aware.
Yeah.
And it knows which one it needs to pull down. We also have a capability to alias a family of models. And so one of the things we could have done is added an alias to this and say badge detection latest. Yeah. And the runtime is smart enough to know that, hey, there's a new version of this model available in the same family of models. So I don't have to, so I can upgrade automatically to the latest version, or you can pin it to a specific version.
And the SDK, which language do people use for the SDK?
Our two big ones are the React Node SDK, good for TypeScript, JavaScript applications, and then of course Python.
Okay.
And we'll be showcasing a little bit of both today on the laptop. Okay. So now that we have our model, we are ready to deploy to our Qualcomm laptops. This is a Windows-based runtime. So this is our documentation. We're going to go into our how to train a model deployment and then deploying to Windows runtime. The first thing we're going to need to do is actually download the runtime. This downloads to the device. This is for development. We have a package for packing into your executable if you're distributing this. But this is great for this sort of testing that we're going to be doing today. This runtime, once on the device, we're going to start it up. And so we can see we have our iPop Edge SDK service. This is now started, and we can see that it's listening locally, and that is how the local development happens. And so we see that's local there. The first time through, you will have to put in your API key. That's what authenticates your development runtime to your account. that allows you to pull down your custom models. Otherwise, they wouldn't be, we wouldn't have the authentication to pull down your models, just the standard ones. I'm also going to set my environment variable, local true, and then I'm going to paste in my model UUID here. And so to showcase kind of how you would use our Python runtime, start off by importing our SDK. I'm going to import a couple of other things. I like pretty printing the JSON. We're also going to use Pillow and Matplotlib for some visualization. And then to mess with the file system and write files, we're going to use the OS. In here, I have some example images that we're going to be using today that were not part of our training set. And I'm going to connect to the iPop worker. Now, using it in local mode, it's pretty easy. You're just going to call worker endpoint. That sets you up, no other configuration happening. In the cloud, you give it a little bit more authentication and configuration there. The next thing I'm going to do is I'm going to set the configuration for my POP. That's my endpoint. In this one, we're going to keep it really simple. I'm just going to use a single model in here, but I can give this a list of models. These models can be from our library. I can also give it a directed graph of models. And so I want to find the badge, but then I want to find the text specific to that badge. Where I want to find a person and I want to find if they have a badge, and I also want their body landmarks. And so you could really get pretty complicated with the amount of configuration that you have here. And it's going to automatically configure the pipeline to run all of those models together. And my JSON output has that same structure as how I configure this.
Yeah, I'll just pop in here. So we talked about VLMs earlier, and you might be thinking, well, that's a lot of models to chain together. Maybe a VLM could give you something there. But I think one thing that's really nice about this, even if one of these models were a VLM, being able to crop out an area and then actually send that to a downstream model really gets at this idea that you can actually verify what the VLM is telling you with a much more specialized model. So one talk that I've seen at EVS that I really enjoyed was the keynote yesterday, and there's some awesome work coming out of Trevor Darrell's lab that'll be coming out at CVPR. Around generating but verify. So you can generate answers, but then sometimes you want to go back and verify what you have. And so this is a way where even if you're using a VLM, you could compose that with a more specialized model to get a verification of what it said, or maybe some uncertainty information around it that you didn't already have. And so I think that's something that's very powerful about this kind of thing, that really, being able to chain these models together enables to be able to get, that layer of certainty and value out a little more directly.
And this quarter, we're all about enabling both zero-shot detection as a capability within our POP architecture as well as VLM. And so you'll see in our docs over the next couple of weeks, we're going to be throwing out some new features there and new capabilities that you can use within your endpoints. And so the capability of coupling a VLM with a really specialized computer vision model is something that I'm excited to get into. So once we have our POP configured, the rest is just running the inference, which we'll do through result upload and predict. Once we have that result, we're going to dump that JSON just out to the console. And more interestingly, actually augment the image source file with our visualizations of the bounding boxes that we find. So let's go ahead and run that. And here we go. And so the first time I'm running this on this device, it pulls down the model and then it goes right into the inference. And so what we're looking at here is the NPU. And so we're only running inference on this one image. So we're not going to see a big blip here. When we get into the next demo, we'll see a little bit more NPU usage. But this is actually using that underlying NPU hardware on the Qualcomm Snapdragon device.
Yep. So the AI Hub is kind of packaged this up so it runs directly there, and then we're providing the pipeline around it. So you don't really have to do anything specialized to run this on this laptop, besides what Andy showed there using our Python SDK.
And all of our runtimes for various devices do the same thing. They use the hardware how they're supposed to use the hardware. and so that you don't have to think through that configuration there. Okay, now let's take a look at the result. We can see in the console, the tail at the bottom there, we're definitely getting some interesting looking results. I like to verify by image first. That makes more fun. And so we can see our CEO, Brad, at our booth. Come by if you're at EVS and come say hi. But we can see it found his badge. So that's looking pretty good. Let's go and verify on another image. And so we can see the difference between the non-visualized image, that's the input image, and our predictions. I'm going to, let's put the other image live and we'll run this again. And so this is an image of me also at the booth. And there we go. So we got predictions back nice and quick. This is the source image. Let's see if it found the badge. All right, looking pretty good. All right, so I think this model is ready to put into a bigger test application. And so we're going to go ahead and we'll close out the Python. We could have done this all in Python, but I wanted to showcase both SDKs. We're gonna jump into our React app. And so what we've done here is put a nice just visual shell around our capability here. Using iPop, same thing. I'm going to add a capability to my POP. And so in the React SDK, slightly different syntax here, but same idea. We're also adding in a confidence threshold. And so we found through testing, 0.9 confidence threshold is a good place to be for the app that we eventually want to create. Now, I could have done confidence thresholding in post-processing also. This puts it into the pipeline, so I'm not even going to see results under that confidence threshold. It cuts down on a little bit of the chatter. It depends how chatty those results are back. It also cuts down on the post-processing code I need to do. Once that model is in there, same thing, I'm going to initialize a local endpoint. And so you can see I've code here both for testing our cloud endpoint as well as our local endpoint. This is running in local mode. And that's, that's pretty much all I have to do on the iPipe side. The rest is the UI I want to place around that. I will get alerts now in the code to hook into when we do see a result back. And so this is the app. It's just a live preview with how many badges we found. We have a little text running at the top. Now at the bottom, we were waiting for the endpoint to connect, pull down the model on this particular device. And then now we're ready and we're scanning. And so this is scanning at 3 times a second. We could bump that up if we wanted to. We found that was a good amount of time in for our particular use case. We can see it's finding badges pretty nicely here. And so we'll actually be running this at our booth if you want to come check it out. We're also going to show off how we're using the NPU. And so this is running 3 images through a second. We're not really touching that NPU very much with one model. And so it's looking pretty good there.
Great.
Okay, that's good. Yeah.
So I think
one question I have is, okay, so let's say you want to build your own application, a mobile app with the runtime. What is the size of the runtime that gets included in the app?
That's a great question. It depends on the system. The development preview for Windows, actually pull that up right here. It's fairly small. All this is meant to be something that gets included in here. The package that you would distribute is going to be roughly 100 megs in there. And then on the mobile phone, it's much smaller. It's really just tiny things that you would include into your APK or iOS package. Yeah.
So, small enough to fit on a zip disk for everyone old enough to remember those.
Yeah. Yes.
Yes.
I got to give the chat something to laugh about.
Yeah.
I don't think we should bring back measuring size in zip disks, but
Well, no, I mean, in America, obviously, we would measure it by how many football stadiums
Yeah,
yeah,
it is.
there you
That's the standard unit of measurement here in the
right,
U.S.
anything but the metric system, right?
That's right. That's right. We got a bunch of questions here. I think we can ask a couple, but first, let's do our trivia giveaway for the folks out there watching on Zoom. I'm going to go ahead and replace the spotlight here. Hopefully, it will pop me up. Let's see if it actually works. Yes, it did. Hey, everybody. In case you need a reminder or you're joining us for the first time, one of the things we do on this here program that you're watching is a giveaway to you in the audience. I've created a trivia question based on today's episode, the presentation from our illustrious guests. And the first person to answer that question in the Zoom chat with their messages set to everyone, not just hosts and panelists, will win the OpenCV University course of their choosing. You can see what courses are on offer by going to opencv.org/university. Before I ask the question, I'll give you a few seconds to get into Zoom. If you're watching elsewhere, it's at opencv.live. That'll just pop you right into the Zoom meeting if you're on YouTube or Twitch. Before I do that, though, we're going to talk a little bit about why it's important to support OpenCV and how you can do it. One of the ways you can do it is by going to opencv.myspreadshop.com, picking up a shirt, a hat, a hoodie, a pet bandana, any one of these fine products, including the iconic Import CV2 statement. Make a statement with OpenCV. It's all you really need. You can also get the OpenCV logo and all this merchandise, as well as the I Love OpenCV logo in English, simplified Chinese, and en Espanol for all of our Spanish-speaking friends out there. You can also sponsor OpenCV on GitHub, and we are so thankful for the 13 sponsors we've got over there. I'll give them their 5 seconds of fame really quickly here. We've got LivePeer, we've got DJ Greenwood, we've got Rudis Laboratories, we've got Tala Hussein, we've got the homies at RoboFlow, we've got Brian Bjark Jensen, we've got Alexander Ismailov, we've got Comet ML, we've got Jonas Heinle, I believe is how you say that one, Nick Libertini, Blue Jay, Jesus Anaya, and Victor Bedavato. We appreciate you all so much. You can be as cool as these people by going to github.com/sponsors/OpenCV for $9 a month, and I will read your name out here, pending editorial passing editorial muster. One of the things you can opencv.org/university industrial strength computer vision and AI courses from people in the industry. We've got a brand new course over there. Go check that out. You can also donate and support OpenCV that way. If your company uses Benevity and does matching donations, ask your boss if you do this. That, for example, if you want to donate $100 to OpenCV, your company may very well match that and make it $200. Every little bit helps. We're a nonprofit organization that puts out free open source software with very few restrictions, if any. And as such, we depend on the donations of individuals and organizations to keep going. You can also donate as an individual via Stripe or via PayPal. If your company uses OpenCV heavily, consider becoming a member organization. We've got bronze, silver, and gold membership tiers. You can see all about the various perks you get as an OpenCV member, including appearances on this very program, OpenCV Live, as well as being able to address the global OpenCV community in our newsletters, which go out to 320,000 people every single week. That can be you. Hit us up. You can also buy a t-shirt, as I just said, and volunteer. We always need help spreading the word and maybe writing some computer vision code. So please check that out. Having said that, get ready for trivia. So I know y'all get a lot of questions here. I'm excited for the questions as well. We got plenty of time for those. I have a feeling that you're inside my head, and this one is going to be like lickety split. So let's see. If you have won in the last couple of months, please do not answer and give someone else a chance to win. Remember, your messages must be set to everyone here in Zoom, not just hosts and panelists. There's a little drop down you got to check there. So, one of the things we're seeing on this episode is the awesome Qualcomm laptop there. It's a very tiny thing and very fast. What is the model name? Bam. See, they got me. They got me. I think Bill Blair, you were a little bit quick, buddy. A typo. I think we got to go with the second answer here. Satya, can you pronounce that name for me?
I cannot actually see the screen
No,
very.
it's Partha Senarthi. Partha Senarthi?
Yeah.
Okay. The Snapdragon X Elite is what we were looking for there. Bill, you were so close. Bill's answer was Elite X Snapdragon Qualcomm. It's like a little bit of word salad. We value accuracy on this show. So congratulations to Partha Sathari. Please send one email to me. That's phil@opencv.org with the name of the course that you would like. Go check out those courses at opencv.org/university. And let's switch to the gallery view here because we've got some questions from the audience. Before we do questions, I'm going to remind people, come by Embedded Vision Summit today, OpenCV booth number 704, iPop booth number
804.
Yeah.
Oh,
804.
great.
Fantastic.
Easy to remember.
Yeah.
It's right. It's just right on the back. Yeah, you're on our back there like that. Isn't that a Foo Fighters song? We've got OpenCV stickers, buttons free for everybody out there that stops by. We've got some leftover OSCA stickers as well. Celebrate OpenCV's first ever in-person conference. And of course, we've got the cute little 1-inch buttons. Everybody's lanyard needs an OpenCV button, and every laptop needs an OpenCV sticker. Question time, yes. So we've got a few. So one of the ones I saw a few questions about here was folks are asking, how can they try iPop? Is there some way to sign up and try out this nifty service?
Yeah, absolutely. We have a free trial for 30 days, and so it gives you a good sense of the platform. It's fairly unlimited, and so you can do quite a bit of stuff in the free trial. Then it's on the developer plan, which we call Basic. It's $20 a month to get access to both inference and training. You just pay overage fees. When you want to get into production, one of the things that we recommend is moving up a tier to our production tier. That guarantees you inference capacity. Otherwise, there is a little bit of startup time when you start your pipeline.
Okay. That makes sense.
Yeah, come check this out.
Thanks for that. That makes sense. And yeah, you can just go to ipop.ai to check that out. Another question here we got on YouTube from Go Data Prof. Is iPop hiring?
We're small, but we probably are hiring later this year, and so definitely my email is andy@ipop.ai. Any other questions or resumes you can send to me, and I will pass to the appropriate team.
Fantastic, yeah. Pankaj here would like to know, like what other restrictions might there be on the free 30-day trial here for iPop, just to be above board?
Sure, absolutely. So the way our payments work is you pay for the GPU time and capabilities that you use, and so on the free trial plan, you have a certain amount of inference time. We find it's enough for people kicking the tires and building small solutions in development mode. You're also limited on the amount of trading iterations that you have. You can pay to upgrade that, and then as you move into higher tiers, that just gets upgraded.
So do not use the free tier for production.
Yeah.
Was that? The pricing's better.
Yeah.
Yeah. So I think, and then maybe we should talk about our other tier pricing as well.
Sure.
The basic plan is $20
Yes.
a month.
Yeah.
We're trying to really kind of get people to use the service, drive adoption, get feedback from you all about what you like and so on about the platform. And then our next tier up is our developer platform, or developer tier, and that's the $99, I believe, right?
Yep.
Okay.
And it's all just bigger chunks of inference time, more training, and then once you get to a place where you want to deploy this in production and have dedicated capacity, then that starts at $200 a month.
All right, yeah, thanks for that. Couple more questions here. We got a
One
few.
one
Yeah, we got a few.
question.
Go ahead, Satya.
When, let's say, there is a small developer, they start with the $99 a month,
Mhm.
and suddenly they start seeing traffic. Can they switch over without changing anything in the app?
Yes,
Yeah.
Just switch over by upgrading on the website.
that's right.
Okay.
Yeah, you don't have to change your implementation at
Yeah.
all. It
Yeah.
just passes through.
Yeah.
Yeah, and I think that's one thing to point as well. We've kind of set up the pipeline, so they're really focused on capabilities and so on. So we
Yeah.
have like person detection out of the box, but we are continuously looking for ways to improve that capability. And so if you're using that capability with our platform and we improve it, you also don't have to change your code at all.
Yeah.
In order to get those kinds of benefits.
Awesome.
Yeah, excellent. Good answer and even better policy. Yeah, so another question here was about, so we specifically were looking at the Snapdragon hardware today, but what other types of hardware does iPop support?
Right now, behind the scenes in our staging system, we support mobile phones, so doing inference directly on the phones. Same exact code that you saw in all of that. We want to work in Swift, Java, React Native, those types of mobile things. That is our entire next quarter. We have some customers that are so eager, they want to use our pre-release version of that runtime, and so behind the scenes they're integrating that right now. But if that is interesting to you all, please reach out. But we'll have that capability very soon here later this year.
Yeah, looking forward to that. And hey, it's a good problem to have when your customers are too excited. I think is there is such a thing, but it's there's worse ones. There's worse problems. Yeah, we've also got let's see here. So one question from me is, and somebody highlighted this on Zoom as well. Obviously this is a cloud-based system. How does IPOP sort of work with some of these data privacy laws and healthcare stuff like HIPAA, or PCI, DSS, GDPR, all of the word salad of regulations? How does IPOP deal with that?
Yeah, so generally, any data that you upload into your account is your data. It is, number one, we don't use it to train anything but the things you want it to train on. We have data separation so that we're not looking at that data. We're end-to-end HIPAA compliant. And so we do have use cases right now in our customer base that require that sort of compliance. And so we understand that well. Do you want to add any other pieces to that?
I'll just add that, some places they will, if you upload data into their system, they will use it to train their own models. We do not do that. That's not something we're doing. We're trying to enable capabilities using a lot of the off-the-shelf models and improvements that we make to those with public data sets, but we're not trying to leverage customer data for that purpose. We're trying to use the open and public information out there. And again, where our goal is to really make it easier for people to build their own capabilities on top of those things, not necessarily to, improve, like have a proprietary model or anything like that.
When inference happens in the cloud, when it happens on premise on a device, that's easier to lock down on where my data is going. But what's happening in the cloud is an AI worker is pulled out of our pool of AI workers. That was that startup time that we saw when we were creating the endpoint. When that workers retire, it's wiped and put back into the pool. And so you don't have any commingling of device or instance of like my data that has gone through that particular server.
Yeah, that makes sense. I really do appreciate the. It seems like it's very common these days that I think it's fair for people to assume that if they're using an AI on like an image service with AI, that they're just going to try to take your data and use it themselves. And it's nice that you're not. Like I really actually appreciate that, because I think it's become too common that it's just people assume that that's what's happening because the product is not the actual product. The product is your data. The product is you. As we used to say in an earlier time of the internet. Are there, so this one's from me, like what are the plans for future expansion? If you can talk about any of the sort of, forthcoming stuff from iPop within the next, say, 6 months to a year.
Yeah, and so we're excited. I know you all are excited for later this summer with OpenCV 5. We're excited for our video agent and VLM integration natively into our pipelines.
Oh, wow.
And so video agents, we are building that right now. In this quarter, it's a lot of architecture to do it right, and we want to have all of that together in a way that somebody new to machine learning can come in and pick our video agent off the shelf and just start using it. So the implementation code is going to look a lot like the capabilities we showcased today, but there's going to be prompts in that initial configuration along with the models that I want to identify to use. Blythe, do you want to talk about some of the technologies we're using for that?
Yeah, sure. So yeah, as Andy mentioned, we're hoping it looks exactly the same as a POP, like any other model. We're trying to make it that easy to use and integrate. Under the hood, we're using VLMs, we're using various vector databases, we're using LLMs, and one of the things we're working on actually actively right now is bringing those into our current system and getting them deployable to the edge. So actually right before we started this webinar, I was talking to Megan from the AI Hub about how we're different ways we could collaborate on getting that directly to the edge. So that should enable people with our training system, which should work with the VLMs directly. You should be able to fine tune those and send them to the edge. So we're really excited about bringing that capability on board into iPop and making it just as easy as you just saw to do a badge detector to actually deploy, to train, fine tune, and deploy a VLM. So those are some of the things we're excited about. I think we're also planning to move to, expand our group of edge devices. So we've focused a lot on Qualcomm. They have the AI Hub, which really makes that very a nice way to integrate it. Moving to mobile, Andy mentioned we have some initial things there, but we'd like to make that fully available to everyone.
It's awesome.
Exciting
A
stuff.
little bit about the video agent. There are two words there, right? Video and agent.
Yeah.
So can you elaborate on both of them?
Yeah, sure. So our pipelines now, they can ingest video for the POPs that we currently support. VLMs are much heavier. And so we're working to try and make those, our implementation of those handle video as well. And so that would basically process a stream of video in addition to or you could do individual frames.
Yeah.
So that's the video ingestion part. So getting that to go through the VLM part of an agent is an optimization process, especially if we're moving it to the edge. And then the agent part is really bringing a lot more context to the VLM. So a VLM may have some context window and so on, but if you want longer term context windows, that's where you might have an agent that comes in. So one fun example use case we've gotten is, I'm sure everyone's seen these demos where you take a picture of your food and it tells you how many calories are in there. Imagine doing that for, I don't know, several months, and then asking this agent to say, did I eat healthy last week, right? Or did I eat healthy in February? Like that kind of question, those kinds of things that have much larger context windows and so on is something where we're actively working towards, because that's a capability we see a lot of our customers interested in that requires computer vision, but also this kind of agentic approach that's doing the VLM, but also all of the context integration across different timescales.
So one other context in which the word agent is used is controlling your, let's say, phone, right? Will that be part, like you say, book my Expedia ticket from this link, right? And it takes snapshots of your screen and it is able to navigate. Will that kind of application be enabled also?
Yeah, we haven't been focusing on that one for this summer. We've been focusing on an agent more as like, think of it as a detective for all the videos and images that you might have. And so that's kind of where it would go out and find all the relevant information and summarize it in some way. So not so much someone that's going to, book your dinner reservation, but someone that's going to help you understand your data. Basically.
Makes sense. I think, we hit the hour. We parallel parked this episode right up to 10 o'clock. Great job, everyone. Reminder, OpenCV will be at Embedded Vision Summit, and so are our lovely friends from iPop, 11 a.m. to 5 p.m. today in the exhibit hall. There's not a hell of a lot else to do in Santa Clara, so stop by and come say hi. Santa Clara Chamber of Commerce is going to come down hard on me for that one. But yeah, I'll be there. Satya will be there. We'll have some button stickers, pins, and friendship for you. I think now is the time to say goodbye for today. I'm not going to sing you a song, but I am going to say thank you so much for watching out there, everyone. We could not do this show without you. Not only couldn't we absolutely would not. And thank you so much to our guests. I'll see you guys in a little bit as I hop a cab back down to Santa Clara for the exhibit. Thanks, Satya, for helping put this show together as always. And OpenCV Live will return next Thursday with, I think maybe we should do an OpenCV 5 update. What do you think, Satya?
Yeah, we can do that,
Yeah.
or we can do a tutorial or something. Well,
Yeah, I think that's what we'll do. We'll do some kind of informational OpenCV thing next week on the show. 9 a.m. Pacific, same bat time, same bat channel. Take care of yourselves out there, folks, and take care of somebody else if you can. It's a rough world out there. Have a great day wherever you may be.
Thank you.
thank you.